So with these, you can write down as much as you want on here, but an actual vector, it's basically a line segment with direction. Okay, so it's kind of like a ray. It has an endpoint, it has an arrow. When we're talking about a vector, the first letter gives your starting point and the second is your ending point. We are only going to focus on position vectors. So we aren't doing much, we're just looking at vectors where they start at the origin. So we will really, out of all of this, we're just looking at the case. You're going to see a vector has kind of like an ordered pair, but it has segments or little brackets on it. And if I say vector AB, it means it's starting at the origin and it ends at point AB. It's just like a segment that starts there and goes there. Sometimes you might see it with an arrow on the end. But we're only talking about the ones that are giving position. So starting at 0, 0. The first thing I'm going to ask you to find is the magnitude of the vector, which is just the length. And you could do it right now, probably just from what we already know. If you think about SOHCAHTOA, the horizontal distance would be A, this is your B, and that would be your C. And then you can do Pythagorean theorem and solve for it. And that's essentially what it is. The notation is a little bit different. The magnitude, vectors are usually written with a bold letter. And so it has like absolute value symbols around it and it's bold in the middle. That tells us the magnitude or the length of that vector. And it's just the square root of a squared plus b squared. On our formula sheet that you're given for everything, I have all of our formulas for vectors on here, so you don't have to memorize it. The other thing that I might ask you to find is the direction angle. And that's just saying, if you think about our picture, what is this angle right here? And if you're trying to find that, we know that if this is the right triangle, opposite and adjacent, that's tangent. So to find our angle, it's the angle where tangent of theta is equal to b over a. So that's the second thing. If I ask for the direction angle, we'll use tangent to help us find it. If I ask for the magnitude and direction of this angle, the magnitude, if you were really in a pinch, you could draw a triangle and find this. Now if it's 3, -2, it's just kind of like an ordered pair. +3, -2, it's just saying it starts at the origin and ends there. So you could do Pythagorean theorem, or you can just use that shortcut formula that we're given. The magnitude is the square root of a squared plus b squared. So the square root of 3 squared plus -2 squared. And 9 plus 4 is 13. So magnitude is the square root of 13. If I ask you to find our angle, we are going to use that tangent of theta is b over a, opposite over adjacent. We also do know what quadrant is this one in. +3, -2, that's in quadrant 4. So, tangent, my b is -2, my a is 3. I don't know when tangent is 2/3 off the top of my head, so we have to do the quadrants and reference angles. We know we want it in quadrant 4. So to get our reference angle, just do tangent inverse of the +2/3. And then to put it in quadrant 4, you just do 360 minus that value. So that's our direction angle. Any questions about that? The second thing, there's a form called polar form that involves vectors, and so we're not really going to do polar form, but we do need to talk about horizontal and vertical components. Think about it on our unit circle. We know on the unit circle x represents cosine and y represents sine, right? The thing about the unit circle is the radius is always 1. So if you wanted a bigger circle, your cosine and sine wouldn't be the true values anymore, right? So if my radius were 2, I would actually have to take it times 2 to get there. If my radius were 4, I'd have to take it times 4. So if I ask for horizontal and vertical components, if you have a vector, it's just the magnitude times the cosine for the first value, the magnitude times the sine for the second. Again, this is on your formula sheet. So all of this is labeled. These are just questions that you might be asked about your vectors. So make sure you horizontal and vertical because your x value is the direction you travel horizontally if you're plotting a point. Y is your vertical distance if you're plotting a point. So we use these if I have the angle and the magnitude and I'm trying to write the vector. So the last problem I gave you the vector, we found magnitude and direction. The next one I'm going to give you magnitude and direction. We have to write the vector that goes with it. Okay, so if I tell you vector W has a magnitude of 25 and the direction angle is 41.7 degrees. We're trying to write the vector. So if you think about if I were plotting this, 41 degrees, that would be in the first quadrant. I gave you this angle. And I'm telling you this length is 25. And so you have to be able to tell me what are the x and the y that would make that true. And so to do it, we can just use our formula. Our horizontal, that's like our x. It's just the magnitude times the cosine of our angle. So my magnitude is 25, cosine, my angle 41.7 degrees. So I plug that in. Get 18.7. Vertical, that's your height, so it's just your magnitude times the sine of your angle. 25 sine 41.7, and that is 16.6. So we found vector W. 18.7, 16.6. You can zoom on it. Yeah. Any questions here? Let's see if we can write our vectors from this picture. So I have three different vectors, u, v, and w. I want to try to come up with their equations. So if I look at vector u, what is the magnitude of u, the length of it? 5. If you're trying to write the vector, you just need your horizontal and vertical components. So it's just your length times the cosine of the angle. What angle is u? 60 degrees. So we have to do 5 times cosine of 60 and 5 times the sine of 60. Thank you. All right, since 60 degrees is one we know, we don't need our calculators. Cosine of 60 is 1/2. 5 times 1/2 is 5 halves. Sine of 60 is radical 3/2 times 5 would be 5 radical 3/2. Okay, if I want a vector v, the magnitude is 2. Cosine, what is the angle for v? That's w is 280. V is 180, yeah. So we do 2 cosine of 180 and 2 sine of 180. Cosine of 180, cosine is the x, that's -1, so 2 times -1 is -2. Sine is your y, sine of 180 is 0, so 2 times 0 is 0. So vector v is -2, 0. Vector w, magnitude is 6. My angle is 280. So we have 6 cosine of 280 and 6 sine of 280. Because I don't know that one, it's not an angle for my circle, we can just plug it in. So we get 1.0419 and 5.9088. So if I told you to do vector A, B plus the vector CD, you just add the x's, add the y's. It's also legal to multiply vectors by a number. So if I said k times vector AB, you just take both numbers times that value. So that works exactly as we would expect. So our last problem, I just want to do a couple vector operations and then I'm done. All right, so vector u is -2, 1. Vector v is 4, 3. I want u plus v. When you add vectors, your answer is a vector. And so we just add like numbers. So -2 plus 4 is 2. 1 plus 3 is 4. What would you get if you did -2u? Close, except sorry, it's negative 2u. So it'd be positive 4, negative 2. You just take both of the numbers in u times negative 2. Alright, C, we have to do 2 steps. 3u, so we have to take everything in u times 3. So that'd be negative 6, 3. Minus 2v, I'm taking everything in v times 2. So 8, 6. And now I'm just subtracting. So negative 6 minus 8 is negative 14. 3 minus 6, negative 3. Any questions for me there? Do we need another example? Maybe. Let's do this one. Then I'll quit. This is just saying, this is showing you another way that vectors might be written. It's saying u is 2 vectors added together, negative I plus j. I and j are also vectors. You might see that combination, but it's nothing crazy here. If I ask for 2u plus 3v, we just have to take 2 times u plus 3 times v and add like terms. So we get negative 2i plus 4j plus 3i minus 3j. And in like terms, we get I plus j. So it's just saying u and v, instead of giving you the vectors originally, it's already saying they're a combination of other vectors. And you could have the operations from there. Does that make sense? I'll give you your homework from here so you guys have time to get it done. So 10 problems today.